Objective 4, apply the empirical rule. What does it mean when someone says within a certain value? For example, if Leslie is 30 years old and she says she will date someone within 5 years of her age, what age range is she willing to date? Well, if it's within 5 years and she's 30, we take 30 minus 5, which is equal to 25. We take 30 plus 5, which is equal to 35. So the age range that she's willing to date is going to be in between 25 to 35. Now, for example, suppose that 100 statistics students' scores and points on a test are described by the dot plot shown below. The mean of the scores was 70 points, and the standard deviation was 10 points. So for part A, we want to describe the distribution, the shape, the center, and the spread. So what is the shape of this particular distribution? Well, you can see here that it looks like a symmetrical shape, and it's unimodal because it only has one mound. The center is the mean, the median, the mode. Well, the mean of the scores was 70 points, so therefore the mean here is 70. And then what is the spread? Well, the spread is the range, the variance, or the standard deviation. Well, it's given that the standard deviation is 10, so S is equal to 10, and you can see the difference. So from 40 to 50 is 10, 50 to 60 is 10, and so on. Now in part B, it says, find the percentage of scores that are within one standard deviation of the mean. So recall that what does it mean to be one standard deviation of the mean? Well, that means we're going to take the mean, which is 70, and we're going to subtract the standard deviation, which is the one standard deviation of 10. 70 minus 10 is going to give you 60. And then we're going to take the mean again of 70 and then add the standard deviation of 10, which gives us 60. So that means that within one standard deviation, we have to be in between 60 and 80. So what does that tell us on the outside? Well, each one of these dots represents a percent. So if we take a look at this percent, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that gives us the 16% on the left. And over here on the right side, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And on the right side, we have 16%. So the percentage is, since we're looking for the percentage, we know the entire test scores is based on 100%. And then we're going to subtract the two 16%, and that gives us 68%, which means that everything in between 60 and 80 represents 68% of the scores that are within one standard deviation of the mean. Okay, let's go to part C. It says find the percentage of scores that are within two standard deviations of the mean. So we're going to take, again, the mean, which is 70, and we're going to subtract 2, since it's 2 standard deviations times the standard deviation of 10. So 70 minus 20 gives you 50. And then we're going to take 70 plus 2 times 10. So 70 plus 20 gives you 90. So that means the values have to lie within 50 and 90. So we also need to determine what's happening with here. We have two values that tells us that we have 2% outside of that on the left hand side. And over here we have 2, which represents 2%. So if we take 2 and add another 2, that gives us 4%. If we take 100% minus 4%, that gives us 96%. So 96% of the data inside here of the scores that are within 2 standard deviations of the mean. Next, we want to find the percentage of scores that are within 3 standard deviations of the mean. So we're going to take the mean 70 and then subtract 3 times 10, which is 30. 70 minus 30 is 40. Next, we're going to take 70 again, which is the mean, plus 3 times 10. Well, 3 times 10 is 30, so 70 plus 30 is 100. So the percentage that we're looking for has to be in between 40 and 100. So everything in between 40 and 100. Well, we know that this entire dot plot has 100% within 40 and 100. So the percentage of scores becomes 100% that are within 3 standard deviations of the mean.